So this next section is about adding and subtracting mixed fractions or mixed numbers. And so the objectives in this section will be to add mixed numbers and add with carrying, and subtracting mixed numbers and subtracting with borrowing. Add mixed numbers. As far as adding mixed numbers, we add the fractions and then you add the whole number parts separately. There are a couple different ways you can do this also. You can also convert both fractions into improper fractions and do it that way. But I think it's easier to do it this way. So let's say we wanted to add 9 2/3 and 6 1/4. Remember, 9 2/3 really means 9 plus 2/3, right? You're not multiplying there. And this means 6 1/4, right? So this means you've got like maybe a board that's 6 feet long and 1/4 of a foot, right? So that's 6 feet plus 1/4. So you can really think of that as adding the fraction part separately and then the whole number part separately. So what we'll do in this case is just add the 9 and the 6. That gives you 15. And then you take the 8 and the 3. That gives you 11. So just basically change both fractions to something with a common denominator and add the 8 and the 3 together, and that will give you the answer. Right? So if you wanted to, another way you could sort of think about this is you could think of it as 9 plus 2/3 plus 6 plus 1/4. You could add the 9 and the 6, that would give you 15, and then then you'd have the fractions 2/3 plus 1/4, and then just change those to the same denominator. So this would become 8/12, and this would become 3/12. So you get 15 and 11/12. As far as adding with carrying, if the sum of the fraction parts of mixed numbers is greater than 1, carry the excess part from the fraction part to the whole number part. So that would mean if this number back here, this number is greater than 1, right, convert that to a mixed fraction and then just add the whole number part to that. I should mention too that there is another way to do this also. You can add the fractions together, take 3 times 9, which is 27, and add 2, that gives you 29/3, and then plus 25/4. Convert them both to improper fractions, and then add those together and then just convert back to a mixed fraction. That's another way to do it, but I think it's just easier to add the whole number parts and then add the fraction parts separately. If the sum of the fraction parts of mixed numbers is greater than 1, carry the excess from the fraction part to the whole number part. A rubber gasket, let's look at an example here. A rubber gasket must extend around all 4 edges, the perimeter of a dishwasher door panel shown in the following slide. We'll look at that here in just a minute. Find the length of the gasket material needed at 34.5 inches to 23 3/4 inches. Add 34.5 inches and 23 3/4 inches. In this case, right, take this dimension, which is 34.5, this dimension, which is 23 3/4, and add them together. Right. In this case, again, just add the whole number parts and then the fractional parts separately. Right, so 1/2 becomes 2/4, 3/4 would just stay the same, 1/2 would become 2/4, 3/4 stays as 3/4. Add the whole number part, so just add 34 plus 23 plus 34 plus 23, which gives you 114. And then just add the fraction part, right, so 2 plus 3 plus 2 plus 3 is 10, so that gives you 10/4. And then again, this part, right, you can convert that to a mixed fraction, right, so 4 goes into 10 twice with a remainder of 2, so this would become 2 2/4. So you could add the 2 to the 114, right? Because this, again, remember, this really means 2 plus 2/4. So add the 2 to that gives you 116 and 2/4, or you could reduce that by half. Okay. So as far as subtracting mixed numbers, change the mixed numbers if necessary so the fraction parts have a common denominator. Then subtract the fraction parts and the whole number parts separately. So in this case, again, you would just take and go ahead and convert here, right? So if you had 8 and 5/8 and 3 and a 12th, and you wanted to add those together or subtract them, then you'd have 8 and 15/24 and 3 and 1/12. It would become 3 and 2/4. So add the whole number part, or subtract the whole number part, which would be 5. Subtract the fractional part, which would be 13/4. Now, because this is a proper fraction, right, we don't need to do what we did in the last problem. We could just leave that as 13/24. Now you can also subtract with borrowing. You might, in some cases, need to borrow one from the whole number and rewrite one as a fraction with a common denominator both as a numerator and denominator, and add the result of the fraction part of the next number and subtract. So let's say you want to subtract 6 and 3/4 and 10 and 1/8. Let's do that first, and then let's say you want to subtract 15 and 7/12 from 41. We'll do that problem second. One thing I should mention again when you're doing this is be careful. The order does matter, right? So when you're subtracting this, you want to take this minus that, right? Because you're taking 6 and 3/4 away from 10 and 1/8. Now the trouble with that is unfortunately 3/4 is bigger than 1/8, so we're going to have to borrow a number from the 10 and stick that with the 1/8. So the 10 and 1/8, I'm going to write that as 9 and an eighth plus 9 plus 1 plus 1/8. So that'll be 9 and 9/8, and then I can subtract it in that case. So then I'll take 10 and 1/8, convert that to 9 and 9/8, and subtract the 6 and 3/4, which I'll convert to 6 and 6/8. Subtract the 6 from the 9 will give you 3, and then 3 minus 6 will give you 3, so you'll get 3/8. B, for part B, again, we want to subtract 15 and 7/12 from 41. Again, there's nothing to subtract the 7/12 from, so we'll just borrow 1 from the 40 and just write that as 40 plus 1, or 40 and 12/12. So we'll just write 40 as 12 and 12/12. And then we'll rewrite the fraction and subtract. So you'll get 40 minus 15, which is 25, and 12 minus 7, which is 5. So you'll get 25 and 5/12. Okay, so hopefully that helps you guys with that section. So if you have questions about anything, just let me know.